Hello and welcome everybody to Emerging Technology Speaker Series. We're really excited today to explore how augmented reality is transforming manufacturing. So welcome to this session. I'm Lee McGrath, the Director of Business Retention and Expansion at the Windsor-Essex Economic Development Corporation. And joining me today to introduce our speaker is Vladimir Francho. Vlad is the local industrial technology advisor for the National Research Council of Canada, heading up the Industrial Research Assistance Program. And he was our connection to DataRealm for this presentation. Also, I did want everybody on the call to know that we will be opening up the Q&A. So if you have questions, put them in the Q&A chat box down at the bottom of your screen, and we will try to get to as many of those questions as we can. If for some reason we can't answer your question during the time we have allotted today, we will certainly follow up. So welcome, Vlad, and thank you for doing the introductions to Alan.
Thank you, Lee, and welcome everyone. Our hope was to see everyone in person this year at Caesars Windsor, where usually our emerging technologies in automation conferences. Hopefully next year we'll get to do that again. I'm really excited to introduce our guest company for today. DataRealm has been an NRC IRAP client and always pushing limits of technology. And I had a great pleasure of working with them over the last 16 years. This is just an example of the latest that they're up to. Our speaker, Alan Ali, is a senior software architect at DataRealm. Alan has over 2 decades of experience in solution design, development, and integration, and is currently leading the augmented reality team at DataRealm. Alan will share with us his experiences and provide real-world examples of how augmented reality is transforming manufacturing. Alan, welcome, and go ahead.
All right. Thanks, Vlad. Hi, welcome everybody. I'm Alan. So, what are we talking about? Iron Man level tech? Well, yeah, kind of, sort of. Augmented reality allows the viewer to see the real world with digital data displayed over it, sometimes as a heads-up display and sometimes as a hologram. Some systems also track the device and the user to enable interaction with digital elements, things like voice commands, pushing buttons, or even manipulating the holograms. So let me quickly specify what I mean by augmented reality, or AR, for the scope of this presentation. AR is part of a spectrum of digital visualization technologies, often called extended reality, or XR. At the one end, you have virtual reality, which is a fully digital immersion, or at the other end, you have augmented reality, where you still see and interact with the real world. And then in the middle, you have mixed reality. For many of the industry's problems I'm going to cover, there can be multiple solutions spanning the range of AR to MR. So for simplicity, I'm just going to call them both AR and stay away from more of the technical details. So AR is transforming the workforce because manufacturers are implementing these solutions to solve these problems. The problems of reducing the skills gap, reducing downtime, creating effective collaboration, visualizing data, and keeping the workforce safe. In fact, many of the previous solutions address several of these problems simultaneously. So let's dive in. I've grouped work and training instructions, or training and work instructions, together because these solutions tend to cover a spectrum from training where you have full knowledge transfer upfront to work instructions where the instructions are always available to assist the worker, to finally workflow management where the solution is directing the worker on what to do and is always on. As you'll see, these solutions work to reduce the skills gap and increase productivity and quality. What they all have in common is that they aid the workers in understanding how to do their job. I'm going to show you an example of 2D AR instructions. Boeing had a problem with the complexity of aircraft wiring and their connectors. As you can see, the worker has to find a unique wire here and then put it into the correct spot on that connector. Going back and forth to a binder or a laptop was error prone and time consuming and fatiguing. The solution? A voice activated heads up display, or HUD, where they say the wire ID and the HUD will display the correct location and insert it into the connector. Now they can have two hands on the process at all times, which was huge for them. This solution increased their productivity, reduced errors, and reduced worker fatigue. Here's an example of 3D AR training. This is actually a video of one of our systems, which we demoed at a local machine builder. The problem it's addressing is the skill gap with new and existing employees. The solution represents a step-by-step instructions of how to do an assembly job. The advantages of 3D AR are more information can be presented to the user. The information has spatial context, so it'll stay put as you move around it. And then you can display different types of information. You can display holograms, shapes, text, images, and even video. We're actually currently working with an auto manufacturer to benchmark this solution for training assembly workers. Multiple manufacturers joined the UK ventilator challenge. Obviously, the production line and staff were not experienced in making ventilators. Using AR training and work instructions, companies like Airbus were able to ramp up their workforce. They were able to rapidly change over production and processes to meet the demand of a rapidly changing marketplace. Besides efficiency, this is a really great example of how this technology can be leveraged to speed up products to market. This is an example from Airbus. Is another example of 3D AR for work instructions. This one's a great example of how holographic overlay can show you where to put your parts. Here's another work instruction example from Volvo. And GE as well found that in tests, first-time workers were 34% faster. So let's talk about workflow management. Stock picking and delivery is one of the most important supply chain activities. As the world becomes more on demand, logistics take longer and are more error prone, thus costly. Mistakes are a burden on the entire supply chain. In this example, the picker has a handheld scanner and is using paper checklists. Here's an example from SAP. With augmented reality has been used to improve their inventory management, reduce picking time, and reduce error rates. These features include complete hands-free pick lists, voice commands while driving, route mapping, and built-in barcode lookup. Here's an older example piloted by Rico and DHL. You can see in the heads-up display, it's telling him where to put the box on the cart. This solution has since been improved and deployed by DHL to facilities around the world. Here's an example of hologram assisted placement. Personally, I think this is really cool, being able to see exactly where it goes. This makes it really difficult to misplace that box. So let's talk about solving maintenance and repair problems with real-time data. AR solutions can integrate real-time data from sensors, PLC and SCADA devices, other IIoT and edge devices, and most importantly, from business intelligence systems like production monitoring, maintenance scheduling, quality control, and logistics. This is the ability to walk around and see data of all those devices without screens. The ability to see all that business information overlaid over the real world, and imagine proactive alerts and reminders from connected devices. Imagine a repairman having a list of work orders and seeing where they are, then being able to walk out to a machine, see its current status, sensor data, open its fault history, and even its service notes. Then open the right AR instructions, repair instructions to get it fixed on the first try. Now, put that same power in the hands of the operator to repair their own stations and save even more downtime. Here's a maintenance example from ThyssenKrupp showing all the relevant data for a job. I mean, in this case, he's got the part information in front of him, and then down to the left, he's got video tutorials and then the service manuals for that part. Another important solution is remote collaboration. Remote collaboration is quickly becoming a huge use case. What's the problem? You have a worker that runs into a problem that they can't, or they don't have the skills to resolve. Even with instructions, it takes an expert's eye to resolve the problem. Before, a worker would have to walk through the issue over the phone or schedule a technician to come when that technician could. Now, what's the AR solution? An AR remote collaboration tool, or these tools are like a Zoom call, where multiple people can see what the person is using the AR is showing and what they are seeing. And the user can move around and share what's going on with all the viewers on the call. But what makes it AR, and arguably the best part, is the ability to draw on the world and elaborate on what you're talking about. Some solutions allow you to import holograms and facilitate digital twinning, which we'll get into. So what does this provide? The amount of downtime something like this can save is huge. It also facilitates collective collaboration, improves efficiency, and reduces risks. Here's another example of Toyota demoing this for remote collaboration on for vehicle repair. Here, the yellow arrows are put by the expert telling the repair person where to go. And then here's another example from Mercedes-Benz. They're deploying a solution to North American dealerships for supporting vehicle repair. If you're working in a remote location, imagine the downtime waiting to get an expert online. Chevron is using remote collaboration to globalize their experts and change delays of days into minutes. Now, with the advent of COVID, there has been an immediate need to social distance and keep workers safe. Both AR training and remote collaboration are solutions we recommend to aid in this. In fact, we recently demoed a remote collaboration tool to an OEM to aid their engineering team's collaboration between work-at-home members and those that had to be on site. This would allow them to see and talk about their subject matter. With that, let's talk about worker safety. Energy and communication companies are also using AR to keep workers safe in remote or dangerous environments. Pictured is what is considered the most dangerous job in the US, a cell tower worker. In the next video, you can see an example of the importance of hands-free systems. So I thought being able to record an issue was just a cool feature until I saw this video. Just give it a sec. So here he's recording a video. Oh, now I know it's actually a safety feature. I don't know about you, but I wouldn't want to hold a cell phone up there. Most hardware has the ability to take videos and take photos. And this is great for documenting your instructions, recording issues, or documenting work completed for quality assurance. Hands-free can mean voice activated, eye tracking, head movement, gestures, or even AI driven. This is an example of safety and an emergency procedure training. This picture is actually showing VR, a VR experience of an oil rig, and learning this before you go on site. Once on site, the same training can be deployed via AR over the real thing to practice, or in the event of an emergency, you could actually run through it. Now, here's another example from Amazon. Arguably, this is more of a vision system than a true AR system, but the AR equivalent could be implemented. So now let's talk about digital twinning. How do you effectively communicate and collaborate on ideas? How do you visualize that? Right now, your tools are printouts, physical model builds, 3D models shown on a screen. Now, let's talk about digital twinning. Digital twinning lets you display prototypes, lets you share architectural, mechanical, and other engineering information. In this picture, this person is actually placing a virtual machine. The idea is that now you can take your design of this machine and see what it looks like in the real space. See, does it fit? Does it conflict with anything else? Here's another example from the Ford Design Lab. It's a shared experience where they can both see holograms. The digital twinning gives the ability to visualize an idea in life size in the real space, have real-time manipulation, move it, resize it, walk around it, switch it out. Here's another example from Volvo. It's a great example showing how you can take your 3D model and strip back layers to kind of have an X-ray vision. This is useful. I think it's useful on the plant floor for visualizing machine wiring. Here's an example from Audi. This can also be used for planning process changes. How many tweaks are there to stations after a new launch? This provides effective collaboration, saves time on building models, eliminates risks by being able to see a prototype in the real space. And I have great ideas for other uses for this on the plant floor, including changeovers and part loading. In this case here, they're using it for planning where the logistic bins are going to go. Here's another example from Toyota, where they're working on a repair diagnostic system. It's a great example of the twinning. This is a construction example. Even though it's a construction example, I see this as a great maintenance tool for finding where your different utility systems are. So let's talk about the future. AR is a jump in the technological capability and efficiency. The same way the PC, the laptop, the tablet, recently the smartphone all incrementally expand that. At first, people couldn't imagine these devices as part of their job, and now they can't live without them. I know when I got my first smartphone, I didn't think, hey, this thing's going to become the camera I use every day. AR is like that. And I'm really excited about the still unthought of use cases. AR is an interface for representing data in a way previously not possible. To get data, to make decisions, drive workflow, and it can actually even collect data. And with more connected business intelligence systems, more powerful AI, I foresee some amazing systems, including flexible manufacturing, where workers build different products from cycle to cycle, where possibly there's load balancing of workers in a cell, taking advantage of open availability, the same way a machine gantry would distribute parts to available machines. Then there's dynamic role assignment, where workers take on different roles during the day based off of what's needed. Another interesting use is robot manipulation, being able to teach a robot via AR with your hands or your body, or route and path setting for things like delivery bots or drones. The future of AR is also as a data source, whether directly from the user or from in the form of biometrics. And there's even an HP headset that can monitor heart rate, pupil size, eye movement, and other factors to discern a user's cognitive load. This would be used to collect data on how a person performs in certain tasks. Maybe they feel overwhelmed or confused. More hardware is coming. These are some of the diagrams. These are some diagrams from Amazon's patent application, and then there's the also rumored Apple Glass. AR is here to stay, is growing. These are just some of the companies we're investigating that already are using AR or piloting it. So is this a transformed workforce? Right now, workers can learn faster, more effectively, pull up instructions on demand without going back and forth, get work prompts, see holographic display over the real life, view real-time IoT and edge data on the plant floor, have expert support to solve their problems, visualize data and designs in ways they never could before, and now they can social distance and still collaborate. So is this a transformed workforce? I'm going to finish off by coming back to this slide that we started with. Well, here, I fixed it by putting a headset on them. This is doable right now. Thank you.
Thanks, Alan. That was really exciting. I loved your presentation with so many.
Thank you.
And you know, we don't have any questions, so I'll start with some questions that I prepared for you on.
Of course you did.
Yes. Well, one thing is a little bit on a hardware. You've used you know, some hardware, which which ones are, you know, pros and cons of each, and you know, what is the average cost of hardware, and also how difficult and how much effort it is to customize these sets.
Okay, there are a lot of questions in there. That's probably a whole talk. So let's start with the devices. So when we're talking about AR to MR, there's a whole spectrum. I mean, you're talking from something that you're familiar with, like having AR on your phone or on your tablet. You know, something as simple as, you know, the people that are playing Pokemon Go or downloading the IKEA app to be able to see furniture in their place. Although I don't think that works in Canada right now. Then you move up from simple displays like that on a flat screen to headgear. So then that's where you're getting into something that people are more familiar with, like say a Google Glass or smart glasses. And the concept there is that it's a heads-up display. So you're seeing the world, and then you see a little screen in the corner of your eye. I think it wasn't Airbus, it was Boeing. The example that I showed from Boeing was a good one, where you could see in the corner of the eye the data. And so with that, it stays put as you move around. It stays in front of you, giving you guidance, but it's not really locationally specific. And then you start to get into, and that's what the I believe that's what the Apple Glass is going to be, although there's not a lot of information on that yet. And then that's what the Amazon glasses are going to be like. But when you're talking about something at like that's aimed more for the prosumer, the form factor that they're trying to go for is more minimalistic, something that isn't as obtrusive. But then to get into the next step up into mixed reality, then the hardware is larger. And we've played with DAQRI. It's not around anymore. And then we went to the HoloLens 1, and now we're using HoloLens 2s. The best alternative comparable, I would say, would be the Magic Leap line. And what that gives you is the ability to see those holograms, like I was showing inside the Iron Man example. So you can see, I can put a hologram of what it is that I need in front of me, both to explain it, like here's a diagram, but then also putting it somewhere and using that to tell me, okay, you're going here, now you're going there, you're going there. Oh, this changed, so that icon changed. Oh, there's I could put a button in the real world. So instead of having to bring a laptop around, I could have buttons on things and be like, oh, okay, I need that. I need to know what that warning is. Let me reach up and click it. Okay, now it's gone. So it's kind of like the immersion that you would feel if you were playing a game, but in real life. So the level of, to your next question about like the level of effort that it takes to get into these all depends on those and the solution that you're trying to do, and whether it's cross-platform and what you're trying to hook into. It's one thing to build to build like a little AR app that's going to run on your phone. I mean, there's tools for doing things on the other devices. But then the really interesting and complex stuff, I think, is, you know, all of these are an endpoint. You know, people just think of it as its own contained system, but really it's the endpoint of a system. It's the input and the output, and you connect it to something else. Or at least that's what's interesting to me. So then you have all these business intelligence, you know, your MES, your FIS systems, and you can have all of this data, and now you can consume that. Instead of consuming it on your laptop or consuming it on your phone, you can consume it in AR with context of what that data belongs to. You know, like kind of how I was saying, you can walk up to a sensor, and that sensor might not have a screen. You know, that edge device that's sitting somewhere, or you know, and then be able to pull up the information for it on your headset, and then walk off to the next thing. And what you call it, it's an input in, and I think that that really hasn't been explored much, in that there's all this information that you collect on it. I can use it, like I said, you can use it as buttons, as a normal user interface, but then you can also use it to collect other things, like how you saw the example of the person taking a video. You can use, like with more powerful AI systems, you can use those cameras for other things, like figuring out whether I think I have seen systems where they use it for or for safety checks, where they walk around and they check, okay, are the systems right? Are all the switches in the right spots? And then it's the AI that's using the camera and checking, okay, like a normal vision system that's using the headset as a vision system, and then giving the person real-time feedback over top of those and saying, yes, this dial is in the right spot. This switch is in the right spot. No, this one's in the wrong spot. So I don't know. That was a dump of information. Hopefully that answered your question, Vlad.
Well, yes, to a degree, but there is we have a question from the audience, from Stephanie. She works for a school board, and they are looking to use VR in skilled trades and for different industries, and
that's a great spot.
Now, and also, you know, they're asking about costs, cost versus benefit. You know, how reasonable. A lot of examples you presented come from large global companies. You know, how reasonable it is for small to medium-sized businesses to do this, and also, and I had a similar question in terms of what industries are leading this when they analyze cost versus benefit. So who is adopting this currently?
Okay. Well, first, before I dive into that, one really cool example for education is the reverse of some of the examples that I gave. Instead of the expert being on the other end, being and guiding the person that's got the AR experience, you can do the flip, where the expert is the person doing the AR experience and sharing with the classroom. So an example would be, you know, a mechanic. So you could teach somebody, so you could have a class that's all remote, and you could put on an MR headset and then walk through the steps of tearing down an engine in front of them, and they would be able to see. And then when they had questions, I mean, if you did that on a webcam, you'd have this process of trying to go back and forth and explain where they're at. Whereas you could actually, as the instructor, you know, you could touch it, but then you could also draw on it and say, okay, well, this needs to go here, and if we were to take this apart, this would go over there, and then they can kind of do that too. And then there are other tools for like virtual presence for shared experiences, where you can have, I'm here, but then I can look over there and I can see a virtual you that's interacting with me. Personally, I haven't got a chance to play with that too much.
Alan, how do they evaluate costs? That's the question.
Okay. Yeah. Sorry.
Cost side, like, how do you justify this? You know, does it make sense? I mean, yes, I can do it.
Yeah, I mean, right now there's definitely a barrier to entry in cost and in expertise. over time, like with any emerging technology, that's going to go down. Right now, there's a lot of companies that are rushing to the consumer level. At the industrial level, which is what we work at. I mean, you can look up the price of a Magic Leap or a HoloLens. I think a HoloLens runs about 5,000 Canadian right now. And then the other part of the other side, it's open ended. It depends on what you want to do with it. That's where I would say, like, if you have more specific questions, hit me up and we can
Yeah,
talk about it.
like in your experience, like, so what industry? You showed quite a few automotive examples.
Yeah.
And
So
are they leading in terms of integration, or is it more construction or aerospace?
I think well, there are other industries that I also didn't hit. I would say that that there's a lot of work in the military space, and then in the aerospace. I know there's been a lot of work with NASA. So anywhere where it's going to first is where you have highly complicated instructions or a high need for collaboration. So those are the spots where you get the highest bang for your buck up front. We're definitely seeing it in aerospace, but then also in manufacturing. In the manufacturing space, I don't think is just limited to automotive. And then, and also, like oil and gas. Those are the ones. Oh, they're medical. Medical is also another one that I didn't talk about, but it's definitely seen a lot of use cases. I know that there's a lot of work from the hardware manufacturers to get systems out to doctors, especially inside COVID. So you've got an example where I can be in a procedure and then have somebody giving me information, or instead of having to look over to the monitor, I can have the vitals in front of me. You've got the social distancing example that I gave you. And then before all this COVID, last time I went to go visit Microsoft, I met somebody that was there that was working on medical training systems where you can actually go through a medical procedure, and they had a virtual cadaver where you could strip back the different layers of the person and then have a scalpel to run through the procedures.
Great. So, and have you had, in your experience with DataRealm, have you had examples or cases where smaller companies, smaller manufacturers were interested, or they saw a business case for them to adopt AR?
Well, I think that's kind of what we're ramping into.
So it's just starting. Well, maybe I can just throw a comment on that. If this session is also meant to spark ideas, and that was the Emerging Technologies in Automation event was always targeting to spark ideas. And if you have ideas and you're looking at maybe some R&D, give me a call. IRAP can help on both ends. Either you can start a project, or DataRealm can help you with it, or anyone else really in terms of contracting. And also, just a note to all participants: you can put your questions, and it's a Q&A button on the bottom, and you have to type it there. Stephanie had a follow-up question. It's which careers are involved in creating AR for all of the different industries? I know this is maybe hard for you to answer, but give it your best shot. Yeah.
Well, I mean, it depends. So obviously there's work for engineers, electrical engineering, process engineers, and then computer scientists. I mean, we work with either deploying and integrating off the shelf solutions or building our own. And so I definitely have developers on my team working on custom stuff. And then, graphic skills, the ability to build 3D models, of what you want for your holograms. And then the same kind of things that you would normally have for any kind of solution integration. You need to have, architects that can understand what your problem is and figure out the best solution for that. So to boil it down, graphic skills, engineering skills, computer science skills.
Great, thanks. On now this one is actually my question. It's a little more technical. I've seen a lot of projects and in machine integrators that use machine learning for predictive maintenance.
Mm-hmm.
They pretty much get lots of data collected and they analyze it and try to predict failure before it happens. Do you see an overlap there?
Yeah.
And that's been already adapted. It seems like here, if you do that and then the technician goes with a headset, it would really speed up.
Yeah, this is where I was saying it's an endpoint. It's your interface to these larger systems. So I'm excited about the capacity to integrate these systems. So in that example, the machine learning system is going to gather that data, or it's going to crunch that data and give results. And then how you want to consume that is up to you. Whether you have a manager that just gets a dashboard or at his desk, or you have a technician that's out on the floor like the operator, and he can see as he looks down at all the say CNC machines that he has, he can see that on the second one it has 10% tool life left, and so then he knows, okay, I need to go do this, or to click on a warning. So it's your IO for those systems. It can also be used as the vision system to collect that information that the AI is crunching.
Great. That's now a little bit back on the cost side. I know you've had cases where manufacturers need to train. They start a new line. They need to train all the operators on the new line. Typically, they do that with people. So someone has to spend time and do it.
Mm-hmm.
And so this is directly would save you that.
Yeah, I mean, that's kind of the concept behind what we're trying to benchmark right now. And one of the big things is showing that you can get rid of that trainer. The ability to okay, I've got not only just new employees, but existing employees that want to upskill. One of the interesting things that I found was that you can take an AR training system for a new employee and you can use it to upskill an existing employee that has some downtime, so that they can go while the line's down and run through the training for the operation next to them. They can either stand at that station and run through it, or they could load it up in the break area and run through it. And you can use that to increase your skills by practicing what are the correct flows and motions, and the run through the various models that you rarely get potentially. So that's all added benefit.
Yeah, great. Thanks, Alan. I don't see more questions on the line, so we can wrap up this session. Again, they're meant to be short and sweet. Everyone can go back to their work day. I'd like to invite Lee back and thank you so much, and invite Lee back to close the session.
Thank you so much, Vlad, and thank you, Alan. What a great presentation today. And thank you for our audience for asking really important questions. We'll be reaching out to everybody with an email thanking you afterwards, and then you'll have our contact information if you need to follow up with any further questions. I really like the fact that we were able to provide this information. It's certainly a topic that is coming up almost every week in our industries and our businesses. And I like the fact that we talked a little bit about how we can interact with students and get them prepared, because I really do believe that the future is going to be it's going to be really important for future skill development that we have students coming up the pipeline who understand. So thank you, everybody, today. We will be holding So we have two parts. We have Recover and Thrive for women entrepreneurs. So that'll be January 14th. And then we'll be presenting to you shortly a March event, which will be a longer event with a multiple range of speakers. So we'll keep you on our mailing list and let you know when that's coming up. In the meantime, if you have any questions for Vlad or Alan or I regarding today's presentation, please feel free to send us a note. And on that note, I hope everybody has a great rest of the day. And again, Alan, thank you so much for the really interesting interactive presentation today. We really enjoyed it.
No, thanks, Lee. Thanks for having me.
Okay, guys, have a great day, okay?
Bye.
Bye.